This question I've been asked to draw these as simultaneous graphs, which means what we're trying to do is find the point of intersection by finding where, if I draw this one and I draw this one, the points of the two graphs, the lines, coincide. So we can do this using a number of methods. First of all, these are written in the general form, which means it's very, very straightforward to actually go ahead and just find the points of intersection. But I'd like to do it kind of more algebraically. So what we'll do is we'll turn these into gradient intercept form, and we'll do it that way, I think. So first one is going to be, and I'll write this out, so it's going to be, it's 2x minus y is 3. I'm going to add y to both sides, and I'm going to subtract 3 from both sides. So y minus y, 3 minus 3, and I'm left now with y is equal to 2x minus 3. So to draw 2x minus 3, I'm going to have a y-intercept of 3, and I'm not going to do too much algebra here because I could actually just say when x is 0, what's y, and when y is 0, what's x. And that would be a perfectly... let's do that. Let's actually do that. So this is my equation. That's the one I'm going to use. So we can say when x equals 0, y is equal to 2 times 0 minus 3, so y is equal to negative 3. Now we've got a coordinate 0, comma, negative 3. Where's 0, comma, negative 3? Let's have a look. 0 along negative 3, and there it is. That's 0, comma, negative 3. Okay, I hope I'm not going to end up drawing a line through that. Let's see if we'd planned it badly or not. So let's do the next one. So when y equals 0, so that's going to be y is equal to 2x minus 3. So 2x is equal to 3, and x is equal to 3 on 2, or if you like, 1.5. So now we've got another coordinate. Here it is. We've got 3 over 2, which is 1.5, comma, 0. Where's that going to be? So it's 1.5 along and 0 up. 1.5 is 1.5 and 0 up. So yeah, that kind of works. Let's see how we go. Anyway, it's going to this is anyways 1 along 2 up. So it's going to be 1 along 2 up, 1 along 2 up. So we're just going to find an idea of where it's actually going to cut. So it should cut directly through that point, but I just wanted to make a number of other points just so it's very, very clear where this thing is ending up. So that is the line we've got. I'm going to draw arrows on either end to show that it is in fact a continuous line. It's not a line segment. And if I was going to be doing this correctly, I'd probably write the name of the equation on the line. And this, by the way, we can write as, this is 3 over 2, comma, 0. That's the intercept there. That's the x-intercept. All right, that is nice. Okay, now we've done the first graph. Let's do the second graph. Second graph is x, what is we down here? Yeah, x plus 2y equals 4. This is nice and simple to do, so I'll do it over this side here. We've got x plus 2y is 4. And what I'm going to do is I'm just going to simply, what am I going to do here? Yeah, I'm going to subtract x from both sides. So 2y is equal to negative x plus 4. All right, that makes it nice and easy. I'm going to divide both sides by 2. 2 divided by 2. So y is equal to negative x on 2, in other words, half x, negative a half x, plus 4 on 2 is 2. So the y-intercept, so we can say when x is 0, y will be, and I'm just going to go straight to the answer now, y would be 2. When y equals 0, that's 0 is equal to negative x on 2 plus 2. So x on 2 is equal to 2. Let's multiply both sides by 2, multiply this side by 2, multiply this side by 2. So x is equal to 4. So we've got another coordinate now, which is, we've got 4, comma, and we've got a coordinate of 0, sorry, a point of 0. The intercept point is now 4 along, 0 up. Let's have a look. So we've got, the first point we had was x is 0, y is 2, so it's going to be 0 along, comma, 2. Here it is, 0 along, comma, 2 is our first point. Our second point is 4, comma, 0. So 4 along, 0 up. So here is our second point. So let's see where those coincide. And let's see, and I can actually see straight away that these 2 points are going to actually, we're going to go right through there. I'll try not to draw through the actual equation to do the point I've got there, but there they are. Now we can see they're simultaneous at this point here, yes? And that point there is 2 along, 1 up. So the point of intersection equals 2, 1. Now notice we haven't done that using algebra. We haven't actually solved these 2 equations simultaneously, but nonetheless we have been able to draw it graphically, and we've found the point where they do in fact coincide. And that's how we use simultaneous equations, or rather simultaneous graphs, to find what is common. So in other words, they're simultaneous when both x is 2 and y is 1.